Hey everybody, this is Larry. This is me going over the 25th day of October Leetcode challenge. I clicked on the button, waiting for it to load. Trust me, because this is now getting awkward. But while you wait, you can hit the like button, you hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Dun dun dun. And eventually it will load, so that'll be cool. Okay, there we go. What was it, 25th? So let's go. 25 day min stack. Okay, so this one is one that I get requests on a lot. And I mean, maybe not this problem, but this problem as a response to different problems, right? Like using this to implement other problems. And I think the thing I would say about this one is really less about the data structure and ask yourself, I mean, not this problem I think actually is easier than this, but for min stack related problem or min queue related problem, as I always say as well, is about asking yourself, what question are you trying to ask? What invariant are you trying to hold? And similar questions where the way you answer it will give you the answer by itself without having to worry about specifically the details per se. Anyway, I'm not going to go over that much more because I think that doesn't make sense without context. So we'll go over let's look at this problem. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And also, I'm solving this live, so if it's a little bit slow, just fast forward. Though this is easy, so hopefully I will get this quickly. If not, then you'll just have to be sad with me because I'll be sad. Okay, let's see. What is this? So min stack, initialize object, push an element, pop the element, and this is on top. Top gets a tab element. So the only thing that's different from an actual stack, a regular stack, is the get min element, right? So get min element, we can do it in, so you can do it in a more space efficient way. I'm not going to do that, but at least not for this thing because I don't want to, yeah, because I want to, I think it's easier to visualize, that's all. There are definitely optimizations that you can make both on space and stuff like that, but I wouldn't worry about it that much. Anyway, okay, so yeah, so that, of course, we need the stack component and then maybe the min component. And what we want to do is basically keep track of any time we push something on the stack, keep track of the current min. Anytime we pop off the stack, we pop off this as well. Keeping track of the per min. It's kind of like dynamic programming, kind of, in that we reuse things, but not really. So don't call it that, and don't, tell people that I said that because then that would be a little bit sad. But yeah, so when push, we push this thing to the list, and then sub.mins. There are two cases, I guess, really. If length of sub.mins is equal to 0, then we just push it in. Otherwise, sub.mins.append either the min of the value or sub.mins of -1. And the invariant here we want to do is that the top of the stack will contain the answer to the min. The reason why we can do this is because if you think about a min stack and as you add more numbers to it, or ignoring a stack for now, let's say you have a list and you want to keep track of a running min, right? Like min of the first element, min of the first 2 elements, min of the first 3 elements, and so forth. I call it the running min. You may think about it as a prefix sum, except for with min, so it's prefix min. So once you do that, then you'll notice one thing, right? Which is that it is monotonically decreasing. And the reason is because there are only 2 things that can happen. One is that the new number that you're looking at is the min number, and if it's the min number, then of course you make that your new min and it becomes smaller. Or it's not, then you keep the previous number, so it's the same number, right? So therefore, if you look at that, it will never go up. So that's basically the idea, and that's basic. And because of that, we know that the bottom of the list or the end of the list will always contain the min. And this is actually relating a little bit, now that we're talking about stack, this kind of related to what we talked about last week as well, with respect to converting a list context to a stack, or to a list solution to a tree solution. And in a way, having a stack is the same thing, in that, now whenever you do a depth first search or a pre-order type traversal, you're pushing and pulling off the or popping off the explicit or the implicit stack. Here we're doing it with the implicit stack. Oh, sorry. Here we're doing it with the explicit stack. So there you go. Anyway, on pop, do we have to return the value? Nope, just pop it. So then we can pop on both sides. And then top, well, just return self.stack, the last element, which is the top. Let me double check for a second whether, like, if there are no elements, okay. So it won't get the pop or top when the it can only be called when there are one element. Okay, so I just want to make sure that's true. And then to get min is just return self.mins of -1 as well. Yep, also. Oh no, also only on open stacks. Okay, because every operation we do here is all of one, so that's why I'm not really thinking about complexity. Usually you hear me at least thinking about complexity a little bit, but this is all these operations are all of one, and obviously you're not going to be faster than all of one. So yeah, I think that's all I have with this one. I don't have any sentinels or anything like that, so I think I'm mostly good. In theory, instead of having this if statement, you can also initialize this with a really big negative number, but I think here it's actually more clear, at least, for most people. Anyway, let's give it a submit. Apparently I did this last year, and I did it this year. 573 days, yay, okay. Yeah, like I said, everything is all of one. Let me know if you have any questions. Yeah, and there is... the way that we built stack and mins in parallel, it turns out that, you can also make it not parallel by only append, because there's no value in appending the same value. So maybe you can take advantage, or you can take advantage of that, but it's still going to be the same amortization, the same cost in general. Did I do anything funkier last year? I don't know. Let's see. No, I guess I did the same thing, except for I actually checked to see if it was 0 elements, but apparently according to the exam, or according to the constraints, we don't have to check, but it doesn't matter either way. Anyway, that's all I have for this one. Let me know what you think. Beginning of the week, so stay good, stay healthy, to good mental health. I'll see you later, and let's finish this month. Bye bye.